having area of cross section A naught and the liquid is emerging with a speed say V naught. The jet will come out. So here I'll keep a surface. So what is the force exerted by the jet on the wall? This emerging jet, it will exert a force, no? So the same formula, there's a wall, force experienced, force exerted by jet on wall should be equal to how much? Rho area of cross section A naught into V naught square. And what is the condition? The jet comes to rest just after striking the wall. Now, similarly, if the wall is also moving, what conditions will come? Let's take even the wall is also in motion. Velocity of wall. In that case, the force will be rho naught A V relative square. Sorry, V naught minus VW whole square. What is the velocity of jet with respect to wall? V naught minus VW. If the wall moves opposite, or wall, or it can be a block. In that case, what is V relative? Then the force will be rho naught A So in what direction the force? The force will be in the direction. The force will be here. The wall will exert a force like this. What is A? A naught? A naught is area of cross section of jet, not area of cross section of the wall. Able to analyze this condition? No, if the wall is inclined, what conditions have to be brought here? Okay, let this be the jet. Last one more. If the same thing, if it comes at an angle. I think there's a quite natural, no? So sometimes we hold pipe. I'll go for better diagram. Now you can see clearly in the diagram, the jet is emerging. So there's a pipe. All of you first, you should be able to understand what is the diagram. There's a pipe. Area of cross section of this pipe is A. Let this be theta. and the velocity is v. With what speed the jet is coming, this one. Now I'm interested in, so what is the pressure on the surface? Pressure, or directly let's calculate the force. How you manage this one. The same idea, just now what we discussed now, the same idea of that is what we are bringing here. What is the area of cross section of the jet is A, but when it's striking, so what surface, how it will strike? It will strike at an angle. Any changes will you bring in your thinking? I will take help of the geometry. This is what area A, no? This is theta. So this should be theta. This should be call this is say some A dash. Area of cross section of jet is A. And what happened? Area of contact of the jet with the surface. Oh. Just I'll get back the screen. Let me finish off. There's a very small topic is there. Then we'll wind up the class. Able to view? Shall I continue?
Yes.
Yeah. Okay, what is our assumptions? I think we have to rewrite again all. Okay, there's a velocity, area, density rho, and there's a pipe. It is making an angle theta. This is the contact angle. Try to see this. So let's get into there's a floor, floor or ground, anything. Or the force exerted by the jet on the ground that we are interested. Now look at the pipe. Pipe it is inclined at an angle theta. So this is the area A, and this will be A dash. This will be theta, no? Will I agree this? So this is theta, 90 degrees. This should be theta. So what is cos theta? A by A dash. So A dash is equal to A by cos theta. What is A dash we should call? What is A? A is area of cross section of jet. What about A dash? A dash should be area of ground in contact with jet. How do that liquid will exert a force? It will exert force normally, no? Or it will exert force in any direction. It should exert a force normally. It will exert a force normally. So therefore the force exerted will be in this direction. So if you take this area, I'll shift this upward. So just what you have to do, we have to take pen, paper, and we should think. That is what we are trying to avoid, because what we don't want any pressure on the area of ground in contact with the jet. We don't want, we want to learn science happily. That's a major problem. Huh? No, let's get into this one slightly. I'll bring that surface. So the force is acting here normally. So we'll resolve this force. This should be the theta. This is theta, no? So we'll get two component of force, no? And this is what A dash. So F cos theta is the net force acting on the surface, force acting on the ground. Force exerted by jet on the ground. This should be equal to Fg, I'll write it. This should be equal to, shall I write F cos theta, F sin theta? F sin theta will be tangential, F cos theta will be normal force, or we'll make it still more clear. It is normal force. This force is what we are interested. Normal force exerted by jet on the ground. So F perpendicular. This will be, I think, more systematic. Will be F cos theta. What is F? What is F here? Rho A dash V square into cos theta. Now what is A dash? A dash will be A cos theta. How much will get? Rho A V square only. Any changes? Anybody wants to object it? A dash is what? Effective area. The force will act in this direction. So I'm resolving that force. So how much it will become? Rho A V square only, that is. The force exerted by the jet on the surface will be. Or you want to, F cos theta is the horizontal force. Huh? Again, look at the velocity. Look at the velocity parameter. Even the velocity also should be oriented normally, no? Even the velocity parameter also should be oriented normally. So therefore here, is it justified writing only V or V square cos theta? I think the V also you should take. Component of velocity directed normal to the this A dash has to be taken, not V. Huh? So here I'll make a changes here. There is no problem with A dash. What is F will calculate. What is F? F should be rho A dash, area of contact is A dash, component of velocity, V cos theta whole square into cos theta. This will be, what is A dash? A dash will be A cos theta, V square, cos square theta, this one. So total how much will get? I need a little bit space. Rho A V square cos square theta. Fine. Okay, this, if you want pressure, rho A rho V square cos square theta will become the pressure. Even the velocity also should be resolved. That's the basic idea.